think we can get started. My name is Hugh Peterson. I am the product manager for our Doseview line of water phantoms. That includes both our 3D water phantom, which I will be kind of focusing in on today, our 3D water phantom system. But we also have our Doseview 1D as well, and I just have a single slide on that, kind of touch on that later on. But the focus will generally be on the dose view 3D. And one thing about the dose view 3D is we really want to help you uncomplicate your annual QA and your commissioning and your acceptance, and anytime you would need a 3D water phantom. Obviously there's kind of four main objectives for water phantoms, for 3D water phantoms. That's your acceptance testing, checking your treatment system versus the manufacturer's stated specs, the commissioning of the Linux itself, checking all your energies, all your field sizes, your wedges, etc. Bringing in all that information and scan data into your treatment planning system for your beam modeling and what have you. And then there's obviously the annual QA, the TG142 tests. There's also the TG51 and TRS 398 test for the monthly QA as well. And then of course there's the just periodic checks if you have a PM or if you have a machine go down, you need to make sure that everything is still working correctly after a repair or a preventive maintenance stop, things like that. So just those periodic checks of beam quality as they're needed. And that's the kind of the main objectives for the water phantom. And with the Dosey 3D, we kind of started at ground zero, maybe 10 years ago or so, with our system. And, we wanted to kind of start with a system that was, like I said, uncomplicated, something that'll give you the information and the data and the scan, analysis you need without being bloated and without being, cumbersome to use. And I think we did that very well. Obviously, what makes a good water phantom, you want a very highly accurate and very repeatable positions for your scans time and time again. You want high quality raw measurements. That raw data, will lead to hopefully less um, post-scan processing and manipulation of the data. So you want to get good initial results from your scans. And with our system, both our software and our hardware, that's very evident that you get very good raw measurements. You want reliable hardware operation year after year. Obviously a 3D water phantom is not something you're going to use every day. And you want something that you can go back to, if you do only best case scenario, use it annually, be able to, not have to fully relearn the system. It's intuitive enough where you can just kind of hop right back in and be scanning in short order. And, with the way we have our system for setup and alignment and things like that, leveling, it's very straightforward. You want that easy setup again, like I mentioned, as you only might be using it best case scenario on an annual basis. And our setup is very straightforward, very easy. We've got some tools built in and accessories for it that make that setup and leveling very easy. And then you want the flexibility and compatibility of the ability to that flexibility to use a whole multitude of different detectors, ion chambers, diodes. We've got a W2 scintillation detector for a very small field. It's a 1x1 millimeter detector. It's got very highly high reviews out in the field. People tend to really like it because of its ease of use. And then, of course, also you want various, ability to import into the various treatment planning systems, and we do that as well. And I'll kind of touch on that as I touch on the software later on in the talk. But the Dosi 3D water phantom, like I said, it's designed and built for uncomplicated scanning and ease of use. Really, it's ground up, built to make your life easier. Hopefully, as a physicist, as we know that you carry many burdens on your backs and wear many hats in the clinic, and we want to make it easy for you when you do need to pull out a 3D water phantom and do your scanning. So, some of the things, we've always talked about, we've put a lot of thought and a lot of work into our hardware. And we always think, you better hardware, you get better data. Much more structurally sound system, more rigidity, things like that, give you that better data. So again, like I said, at the end of the scans, when you're looking at your raw data, there's less post-scan processing you have to worry about. Um, and some of the points of use in there, we use a very heavy extruded aluminum frame. Gives you a very rigid. It maximizes that rigidity. It simplifies the setup, and it definitely retains that reproducibility. We use redundant motors. So in the larger axes, we've got paired motors that are calibrated together, so you get a much more accurate movement. They move together in concert with each other, calibrated together, so you don't have any flexion. It's not a cantilevered system that might cause drag or flexing in the scanning motion. Positional accuracy and repeatability is within that 0.1 millimeter per axis accuracy. So it's a very accurate system and very reproducibility or very reproducible. Sorry about that. We allow for a very quick 3-point leveling, and I'll kind of touch on that as well in a couple slides down the road here. Just kind of talking about some of the accessories we offer to make that alignment and setup very quick. And then, even before the system goes out to customers and leaves the door, leaves the building, we test every system. We have a burn-in period to make sure that the motors are all working correctly and the accuracy is there. We also test every unit on an industrial coordinate measurement system to verify that accuracy and the performance. So, you can rest assured when it arrives at your facility that it's ready to go. Just a few design points that we've kind of taken, details to again make great pains to make that accurate and reproducible scans for you. The water tank and frame are mechanically secured together, so that ensures that long-term integrity and accuracy. We have a small point, but it's a suction drain out at the bottom of the tank. Has a moat system, so you're draining just about all the water out. So no armatures or the robot as we call it, the scanning mechanisms. None of that sits in residual water, so you don't have to worry about calcification or mineralization if you aren't using demineralized or distilled water. So just a small feature, but it's a detail that we took to help you out after scanning once the system is drained. And then we have a fully integrated lift and reservoir cart with a precision positioning platform, which gives you the ability to rotate that tank, for your diagonals to get those very large scans, things like that. But there is also an optional lift cart only that does not have the reservoir, and we do have an optional separate reservoir available as well. A little more on that positioning platform. You have the course rotational adjustments that kind of lock in at either the 90 degrees or those 45s if you want to do diagonals. And then there's also, you can see on the edges there's a black fine adjustment levers for, X and Y and rotational. So you kind of get it into your course position. And then you have up to, 2 centimeters of movement with those levers to kind of fine tune the position of the water phantom. And, it sits on a basically a self-lubricating kind of Teflon platform, so it rotates even with water in it. You can move it and rotate it on that platform. Another point, it's a very versatile system. About 4 years ago, I guess, we redesigned the tank itself with a little bit lower profile, a little more compact design. That we obviously with the advent of the Halcyon and Ethos systems coming out from Varian, we needed to make a system that was compatible with those, and we've done that with the new system. And also, drinking it down a little bit also improve that rigidity and that accuracy component of the water phantom as well. A few other nice features have a wireless connectivity. Our pendant, as you can see here, is wireless, and it's nice that as you walk around and check your runouts on your water phantom for your leveling, you can be assured that you don't have to get tangled up in any cords or anything like that. It has the ability to give you that simple setup and system configuration without tangled cords. The onboard display always shows that scan position, the probe position at any time, and that can be origin set right here at the pendant as well. 3-button speed, so you have fast, slow, and step. Gives you the ability there. One thing, you have the choice of either step scanning or continuous scanning with the system as well. So you have that capability and that's a set choice in the software. There's a bias switch at the pendant. Obviously, with mazes going into the Linux and things like that, sometimes if you're at the console and you turn the bias on there, you go back in the vault, but you need to readjust your chamber, things like that. Leave the bias on. Doesn't necessarily, you don't need to take another trip out of the vault. You can set the bias on or off right at the pendant. Just another nice little time-saving feature. And then we also have the ability included with the system to be either wired or wireless. We include a radio receiver and transceiver system for wireless scanning. It's typically from the wall, the inside wall of the LINAC, where the receiver would be, going to the transceiver on the motion control unit of the tank itself. That gives you the ability to do those scans wirelessly from there. Then the only cable you have is the power going to the wall, but the actual connectivity to the PC is wireless. So it gives you again that good versatility and convenience, not having to trip over or walk over cables the whole time while you're scanning. Obviously, if you're familiar with standard imaging, you probably know our either our CDX electrometer or Max 4000 or Super Max. And we've got a long, well received and highly regarded history with electrometers. So it was an easy um, road to travel for developing our electrometer for the DoseView 3D. It's a charge digitizing electrometer for the high speed acquisition. It's got a very fine 10 femtocoulomb resolution. You've got dual polarity bias voltage choice when you set up your system. And then you also have independent bias voltages. So if you want to use an ion chamber for your reference and a diode or the scintillation detector for your field detector, where you wouldn't use bias. Those are independent of each other too. So you have that setting within the software. I kind of mentioned some of the time-saving features that, again, that's one of our key things to save you time and uncomplicate your life when you're scanning. So we've got a very innovative detector alignment system. You can see on the bottom left center there, you have the what we call the water surface alignment jig, and basically you place that on the chamber, the detector carriage in the water phantom on the scanning arm. And then you can use that image and the crosshair and the X on the system to quickly check your runouts. It's a very quick setup, pretty typical We were just over at Accuray doing some scans, and we set up in about 15 minutes once the tank was filled. With a with leveling the tank and getting it squared away. So it's pretty quick. And the nice thing too is you take that once you have that alignment set up. Um, you can take your as you see on the upper right, there's the detector sitting on that little jig that our scanning chambers come with the build-up caps with the alignment line on there. You just screw that into the holder, place that on that little jig, align the billet cap to the line on the jig, and then when you swap out the water surface alignment jig for that chamber holder, it puts the chamber right in the exact spot you need it. Both level position and in the X and the Y direction. So it's again very quick. Another nice feature with the software is we have an automatic find the beam center, and basically you can set multiple depths for that if you want to do it at surface, and then maybe down at 10 or 20 cm deep, just to check any offsets of your beam. You can do that. And you can check that, and the software will automatically give you the opportunity to redefine your center or your origin if it's off a little bit. That's a automated feature. It just kind of runs a chamber out to the 50% lines, find that 50% line in all four directions, and will give you feedback as to what your left, right, in and out shift should be for centering that, and then you can automatically reset the origin to that position. Very quick and easy. As I kind of mentioned too, the software itself, which I'll get into in a second, also runs our 1D Water Phantom, and so we've got the same software runs both, but a full function pendant, 3-point leveling on this Phantom as well. Two size tanks, so you've got a smaller tank and a larger tank, depending on what your QA needs are for your monthly checks. And it integrates both with our Supermax electrometer and our Max 4000 and Max 4000 Plus electrometers. So if you have any questions on that, we can certainly assist you there too. Along with our electrometer expertise, our X-rated line of ion chambers is very well regarded as well. I've got a long history. We've got a long history with making some of the best chambers in the market. We include two of our X-rated and A28 chambers. They're the 0.125 cc volume. It's a spherical collecting volume, so if you're doing cross-plane or in-plane scans, there's no issues with any kind of beam difference or scan difference from those, because they are spherical volumes. And like all our X-ray detectors, our ion chambers, diodes, W1, W2 scintillators we offer. The ion chambers are a homogeneous Shankar C552 plastic. It's a conductive plastic of the collector, guard, and the shell. So there's no graphite coating. There's no DAG, conductive DAG coating within the chamber itself. It's all constructed with the conductive plastic. So it's a very robust very strong chamber. They don't wear out, they don't really degrade over time or get brittle like a graphite chamber does. And because of that, we offer a 5-year warranty, which is unheard of in the industry. Nobody else offers that kind of warranty on their ion chambers. And another point, we also have an extended warranty available on those to extend that out to 10 years for a very reasonable cost as well. So. Now that was kind of just an overview of the hardware. Now jumping into the software, with the software, we kind of started from the ground up again just a few years back and rewrote our software. Our initial software, we got a lot of good feedback from customers out there, and we took that feedback and kind of built it into the new software. And it's a much more uh, user-friendly and intuitive software to use. It's a very easy, very familiar left to right, top to bottom navigation for working through the software. Like I mentioned, it's fully integrated with our 3D and our dose view 1D software, or scanning tanks, I should say. And you can see on the splash page there where you can see either you enter into the dose view 3D or the 1D side. We like to say there's no hidden features to everything is kind of at your fingertips. You don't have to go searching for two tabs and things like that. It's all very quick and very easy, routinely to move through the software and get set up and scanning in pretty short order. Very intuitive menus for scan queue setup, for measurement and analysis, and I'll kind of touch on those as well. It works all pretty straightforward. We want to do it, obviously as few mouse clicks as possible for you. So I think I'll take a look at the software now. So let me jump into that real quick. Escape out of here and jump into the software. So this is, like I said, this is your splash page, your start page. When you bring it up, it's right here. You can enter into the 3D side or the 1D side for those depth measurements and point measurements. But if you want to do full 3D scanning, we're into the 3D side. Very quick and easy setup. You can set up your clinic. It's very easy to do. Just a few parameters there to put in. Same with your machines. You can add my machine here. You can enter the name of the machine, who the manufacturer is, what model it is, the SAD, the serial number, comment, and then you enter in your energies and your modality, whether it's electrons, triple F, or photons, and enter in your Dmax for your various energies, and that comes is is basically when we're doing depth scans, you can actually uh, force a point at Dmax. So if you're doing a scan path that doesn't necessarily grab a point at Dmax, this will force one there. So that's just a nice little feature as well. So that's setting up your different Linux. So for example, let's see here. I've got three Linux here. I've got a couple of Electros and a Varian True Beam. So and showing as my different energies here. At 6 and 10 on this Linac here, my True Beam. So just things like that. So it's a 6 MV on that one. So these are just demos anyway, demo Linacs anyway. So there's maybe may or may not be true to form. Same with detectors. You can set up your detectors here, what detectors you're going to use. The A28 is the detectors that come with the system. Again, those are our scanning chambers, the 0.125 cc chambers. But you can also here's your D1D diode, D1B diode. We've got an A4, which is a spherical chamber, which some are using as a environmental reference chamber instead of an A28 for the reference chamber. It just kind of sits within the bounds of the tank and is sensitive enough to pick up those pulses for your reference chamber. So very simple again, adding your name, the name of the chamber, who makes it. We're kind of agnostic as far as what we don't discriminate against any chamber company. We realize there's other chambers out there, so you can put any in that you have, the type of chamber, whether it's a parallel plate or a thimble chamber, or a diode, or what have you. You also have like choices, other with or without bias. And that's kind of important because if you choose either a diode or you choose other with no bias, the system will not allow you to apply bias to those. So it's kind of a safety measure so you don't damage the electrometer or the detector by trying to add bias to something that doesn't play well with bias. So we have that. And then additionally, you put your inner diameter in so that when you're doing your dose conversions, that will automatically account for that and put the chamber drop for you. And then the preferences, that's kind of like your time and date preferences, whether your CSV delimiters are commas or semicolons, or your decimal separators or periods or commas. Obviously, internationally, they're different from region to region and country to country. So we get those different abilities there. So, and now I'm going to jump into scan queues, and this is kind of where, one of the things that, we definitely talk about uncomplicating your life as far as setting things up. And, in doing so, I've got the ability to, very quickly drive through and set up those scan queues. It's all set here. You've got your showing you things that are not set. I just need to put something in there and choose my medium, my modality. I'm going to do MLCs for this one. I don't have any wedges or cutouts. Um, and you'll see now that once I put that information in, I'm marked as complete here, so I can move on to my energies. And I'm only going to do maybe 6 MV here. Um, but I can add different energies here as well. If I've got, them set up in my system, I can add my electron energies. I can have my triple F energies, things like that. So those will all appear right here. And then my field size for this, I'm only going to do a 10 by 10 just for demo purposes. But obviously you can set up your 20 by 20s, 30 by 30s, 40 by 40s, 5 by 5s. They don't have asymmetrical um, scan size field sizes as well. If you're using cones, you can switch that and put in your diameter here. That'll populate up here, and you can choose those as well. But for this demo, I'm just going to do the 10 by 10. And now these are all set. And now I go to my scan types, my last one. And I'm going to do maybe cross plane, in plane, and depth for this one. But you can see we can also do diagonals. We can do half scans in the positive and negative in the cross plane, in plane. And then the software later on would stitch those half scans together, obviously, and give you a full field scan data for those. And choose my depths, maybe my Dmax and 10. And then my CAX offsets, if I want to do anything off axis, I can put those offsets in here. Those will populate up here, and then you can select them. But for demo purposes, just inline on the central axis, I'll do those. And then my last one is the scan mode. And this gives you the ability to do a couple different things. This is where you would choose either step or continuous. And step obviously is going to be what your resolution is in millimeters. Continuous will be millimeters per second. I can choose zones if I want a single zone where the resolution is the same all the way across, or I can choose multiple zones and I can change the size of those zones. But if I want to say have lower resolution in the tails and the flat region, but I want a higher resolution in the penumbra region and the high gradient regions, I can set that up accordingly as well. I can choose my like I said, I can choose my zones, I can choose my resolutions within those zones, and I can also choose my overscan distance as well. So very quick and easy setup. Same with depths. As I mentioned, if you're doing a depth scan, you can force that point at Dmax by just checking that box, and it will actually jump as you move through. It'll stop at the Dmax position, regardless of whether it's in the scan path or not. Again, step and continuous here. Zone, you can choose your direction up and down. You can choose your zones as well. So if I have a single zone, just a one resolution, multiple zones, I can have a higher resolution in the Dmax region, as you see here now, if you want. But now these are all marked complete, as you can see over here. So I can save that. And that's really, all you need to do. That's now I have my information here, my test scan. That's dated today, so I can see when those scan plans were made. If I wanted to, I've got very easy copy and edit functions as well, so I can make a copy of that. I have a test scan copy, and I can go in and I can change parameters if I want to edit some of those accordingly to do. Now I want to do maybe my 10 MB or something like that. So I can choose those, and I can use the same parameters and change my energy if I want for all of them. So it's a very quick and easy. You don't have to go through the whole queue process again. You have that the scan queue, and you can adjust those accordingly. So and then yeah, so that kind of touches on the setup. Moving to the measure again, very kind of simple. The nice thing about this too is if you see here, we've got a demo 3D setup. So again, since you're not using the system, on an hopefully anything but an annual basis, you can jump on with the demo mode, kind of play with the software, just kind of refamiliarize yourself with it without being connected to the hardware. So I can turn my demo 3D on, I'll connect that, and for demo purposes here, that's what I'm going to use. So I just initialize the water phantom, and if you're doing this with the connected tank, it'll basically takes the scanning arm and moves it to the extremities of the water phantom, and then moves it back to the center. So I just make sure there's nothing in the impeding the movement of the water phantom scanning system. So choose my machine. I've got my true beam. This is, and you can see here, these are all, you know, red or blue and gray, like the scan queue setup. So gray indicating something needs to be addressed. So I can, here I can choose my detectors. I'm going to use my 828 number one for my field, my 828.-2 for my reference. If I choose for some reason not to use a reference detector, I can click that and then I'll just use the field detector. Um, I can set my dose rates up here. I can check I can put my settling times and my sample times in. Those are all defaulted though, as you can see, but you can certainly adjust those accordingly. And my electrometer, I want to set my bias. Maybe I want to do 300. I want to set that both to my field and to my reference. And like I said, if you're selected either a diode here or a an other type of chamber with no bias, it will not allow you to turn bias on that particular one. So it would be grayed out here to show you that. And then my position here, so I can, once I have my everything settled and set, I probably would have set my origin with the pendant in the room, but you can set it here as well. You can go to specific positions, and you can always return back to the origin very easily with the software. And then here's that locate beam center. And basically, what the beam center is, I can choose both in plane and cross plane. I can choose a specific depth. And then I just turn the beam on, locate beam center. The detector will start moving in the in plane and cross plane positions, finding those 50% lines, and then report back what your shift would need to be in the in plane and the cross plane to truly center that chamber in the beam. And then you just click the shift origin button here, and it will reset that origin for you. But now that you see, like I said, once these are all blue here, I'm ready to start scanning. So I can go to my queue here. I can load that queue. And I'm going to load this one here, which is the one I just did. You'll see they populate here. And the nice thing is too is if I have multiple, if I have like my 6 MV 10 by 10 and a 20 by 20, these will be separated by color too. So, these are all my 6 MV 10 by 10 scans. If I had some maybe 6 MV 20 by 20, those would show us another color band below that. So you kind of can differentiate and see where your differences lie. But I can zero my electrometer from here. I can normalize. So I want to go to my Dmax depth here, move to that position, normalize, and then close. I'm ready to go now. Excuse me. And you'll see here, this is the scan button. So beam on, hit the scan button. You'll see here, you'll see which scan is active right now and what their percentage of completion is. And right now I'm doing a depth scan, obviously. But the nice thing too is while this is scanning, you can, if you have complete scans, you can jump right to analyze, and this will keep scanning in the background. Jump to analyze, and just for demo purposes, I'm gonna grab some scans here. I just want to do maybe some 6 MV scans. And you can filter out what clinic scans, machine scans, your different tags if you have any tags, what date range you want. So you can filter any down to just about anything you want. So this I want to just look at some of my 6 MV scans. If I wanted to only look at my depth, I can do that. I can only look at my cross-plane or my in-plane scans too, but I want to see them all. And maybe, let's see, I want to maybe look at them all. Let me, I do. Sorry about that. I'm gonna do my 6 MB scans. There we go. So I'm gonna, just grab maybe the first, I don't know, 10 or so, or bring those up. And here's my profile scans. Here's my depth scans that I had chosen. We've got multiple different types of things you can do. You've got multiple filters here. You've got a couple of smoothing filters. You've got a Gaussian and a boxcar. All your tools are here. Your point edit, different normalization to a specific value, or normalize at center. You can center the scan. You can do an average symmetric on it. You can do a mirror, either positive, negative, or negative to positive. You can flip the scan 180, 180 degrees. And then you can also do a shift too. So these are all different filters you can see. If you go down here, you can see your scan list here, and you can always open that up to the filters, and you'll see what filters were applied. And then you can always clear all the filters. You can remove the last filter. We've had a physicist, kind of always said, if he's doing scans and then, late into the night, late night physicist would apply a filter, and then he'd come back in the morning, and morning clear-eyed um, physicist would look at that and say, well, why did I apply that filter? You can always remove that last filter. So it's just, something easy to do. But then, again, with my scans, I have my metrics. So I've got, for an MV, I've got my full width half max, my beam center, my edges, my penumbra widths, all your typical stuff, your symmetry and flatness. Um, you've got your different protocols here. You can, the AAPM protocol, you've got the elect IEC, the USA, the variant, the AERB, the triple F as well for specific triple F beams. So those are all different ones you can select. Another nice feature is we have the ability to have user-defined reference scans. So if you want to have a set of scans that you use as reference, you can show those reference scans. And what that does here, a couple different things. It not only gives you a gamma map, which you can set those dose tolerances here, and the distance to agreement. It's preset to 3%, 3 millimeters, but you can put whatever you want in there. Um, but then you can also look down at your metrics here, and well, that always gets me the ding. But that tells me that my scans are all complete, my demo scans, or the scans that you're doing. So if I go back to the measure tab, then you can see that my scans are done. I can jump back to analyze. Like I said, it shows you the metrics here, and it shows you, so the 88 and 89 here are your reference, selected reference scans that you as a user had selected, and then the comparative one. So you have here, scan number 90 ID compared to my reference scan number 89, and this one is my number 88 as my reference scans. So you can see not only the reference scan parameters, but also how they compare. So here's my scan compared to my reference scan. So I'm 0.01 off on that. So it's a very good difference there. You have all those comparisons here. So very quick, easy analysis of your scans. Like I mentioned, you have your gamma analysis here. You have your tools here to zoom in on a particular area of a scan. You can always go back home as well. And then, the other tools you have up here, like I mentioned, the remove the last filter, clear all the filters. You can merge your half scans here. You can save a scan set particularly as a group. But then you also have the ability to export. and your export functionality gives you a number of different things, different areas to export to. Obviously, the different treatment planning systems, Eclipse and Monaco, Pinnacle, Rayplan. We also can export to the CyberKnife Precision. We also to Electa Aqua, which is their QA management package. And then you have the ability down the bottom there as well to export it as a dose view file. So if you have the dose view software, say on your laptop, and you want to do some analysis of scans over the weekend or something like that, you can export them directly to dose view and import them right into your other dose view instance on another PC. You can export them to CSV. We have the ability to produce PDD tables, and then we also do a calculated TPR. So that functionality is all there as well. And then so then you can also import. There's a couple different things we can import. We can import those dose view scans as I mentioned in the dose view format. We also have a tool that is included with the system that allows you to convert and import legacy scans. So if you have an IBA or a PTW water phantom, you can use that tool to convert those to dose view and import them here. So you can do some scan comparisons to some of your legacy scans. And then lastly is the reports. Got a couple different types of reports. You can export into either a CSV file for analysis, the manual analysis, or you can also we produce a isodose curve PDFs as well. So that kind of is DoseView 3D, both the hardware and the software, kind of in a nutshell, if you will. So basically, kind of a quick summary, going through this again, is very intuitive and versatile detector alignment system for a fast setup. It's a very structurally rigid design for very good repeatability and accuracy. Everything is precise down to that 0.1 millimeter per axis accuracy, and we do that in-house. Quick system for alignment and leveling. Got that wireless functionality both in your pendant, but also wireless from the PC to the water phantom itself. Got the fast acquisition electrometer and with the independent bias, full system turnkey. So it includes everything you need. All your cables, all your detectors, your chamber holders. Something I don't think I mentioned specifically. But if you remember back to the chamber holder page, slide, we do include chamber holders for a whole host of detectors, specifically for our A28s. But then we also have a universal holder that will hold just about anybody's cylindrical chamber. But we also have one specifically for our A19, which is very similar in size and scope to not only our farmer chamber, but other manufacturers' farmer chambers as well. Parallel plate chambers, so the Marcus chamber or the Roost chamber from PTW. Those are all included with the system. Something else I didn't mention is that the chambers can be set in either horizontal or vertical alignment on the chamber carriage within this system as well. So if you're using a stereotactic diode that sits in a vertical orientation, such as our D1V, X-rated D1V, you can use that accordingly in the vertical alignment. And then again, our DoseView software, I just ran through it. You kind of saw how uncomplicated, how easy it is to set up, and how easy it is to do your scan analysis. We get very good raw data because of our rigidity and our accuracy with our tank. So there's not a whole lot of post-scan processing necessary, but those tools to do so are there. And then we have the conversion of the depth scans to dose, which I didn't touch on, but it's a one button touch because you put in the the inner diameter of the chamber, so it's a quick conversion there as well. And you can export that to PDD tables and also do calculated TPR tables as well, or to just about all the main treatment planning systems out there also. Um, One last thing to kind of jump through, again, the dose view software, easy left to right, top to bottom navigation, very quick scan queue setup, and easy copy and editing functions. So you don't have to do the same type of, you're doing your 10 by 10, your 20 by 20, your 30 by 30, 40 by 40. That can all quickly be edited and copied accordingly. So you don't have to start from scratch every time, which is a nice time saver as well. Again, no hidden features. Everything is kind of at your fingertips. We've got the export to the treatment planning systems, functionality of importing those legacy scan data from other scanners into the DOSU software, and again, that very straightforward post-scan processing and metrics right at your fingertips. But just something I touched on was the gamma analysis and the scan comparison that was now available in our new 3.2 version. We added the export to the CyberKnife treatment planning system, the isodose curves, and then we also improved our sub-millimeter depth measurement resolution. So now you can do very fine resolution measurements for depth as well.